Good morning, everyone. We are delighted to welcome you all on International Conference on Emerging Trends in Engineering and Technology and Management 2025 in collaboration with Park Avenue Florham Park, New Jersey, USA. This conference brings together researchers, academicians, and industry experts to share their insights. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. IEEE and its members inspires a global community through its highly cited populations, conferences, technology standards, professional and educational activities. IEEE is a trusted voice for engineering, computing, and technology information around the globe. IEEE has over 460,000 members in more than 190 countries, with more than 66% from the outside United States. More than 171,000 student members, 344 sections in 10 geographic regions in the worldwide, 2,709 chapters that unite local members with similar technical interest, 3,635 student branches at colleges and universities in over 100 countries. 4,194 student branch chapters of IEEE technical societies. There are over 460,000 IEEE members in over 190 countries, more than 66% of whom are from outside India. IEEE members are engineers, scientists, and allied professionals whose technical interests are rooted in electrical and computer science engineering and related disciplines. Amity University, in collaboration with IEEE, has come up with International Conference on Emerging Trends in Engineering, Technology, Management 2025. The objective of conference is to address the most essential issues of engineering technology, computation, automation, and knowledge management. It also serves to foster communication among researchers, practitioners working in a wide variety of scientific areas with common interest in improvement of engineering technology and knowledge management related rules and techniques. It aims to bring the academicians and practitioners to jointly discuss and deliberate through plenary talks and paper presentation on the theme Engineering, Information Technology, Operations, and Knowledge Management. The conference will provide a common platform to foster research relations between universities and the industry. The vision of the conference is to bring together technology geniuses in one venue, not only to present breakthrough research in the area of computation and automation application, but also to improve practicality and applications in interdisciplinary exchange of ideas. So it's the time to invite our session chair for the conference today, Mr. Alok Jain sir. Alok Jain sir is a seasoned cybersecurity and financial technology leader with more than 20 years of experience across banking, e-commerce, defense, and large-scale cloud deployments. Now based in California, he combines deep technical expertise with entrepreneurial vision, excelling in secure system architecture, AWS and OpenStack cloud solutions, encryption at scale, and high-performance payment systems. Entrepreneurship and advisory roles, founder of multiple technology ventures and current advisor to AI-driven startups. He has also done many high-impact projects like architected encryption platform handling 10 million plus secure transactions daily, contributed to confidential technologies for the BrahMos missile program. His core strengths include scalable security design, fintech innovation, advanced defense technologies, and technical leadership under pressure. We welcome you to the conference, sir.
Yeah, thank you so much.
So first of all, I would like to invite Mr. J. Karthik Reddy, paper ID 432 with the topic Enhancing Web Security and Vulgar, an Advanced Vulnerability Scanning Approach. Welcome to the conference, sir. Please start your paper.
Hello, good morning everyone present here. I am Karthik Reddy from Vardhaman College of Engineering, Hyderabad. And as a part of our final year project, we we built a project and we also made a research paper on the same topic. So I'll be just sharing a PPT
Just a
of that.
second. So for you, for prior knowledge, you have 7 minutes for presentation and then 3 minutes for question and answer round. Please be a little louder and clearer. Thank you.
Yeah. Okay. So am I loud now? Yeah.
Yes, you are audible.
Yes.
Okay. I'll start the share the PPT. So my paper ID is 432. The title is Enhancing Web Security with WorldGuard, which is the WorldGuard is the name of our web application. And the main idea behind this is because me and my friend Aman, who is also in the meeting right now, so we do some research in cybersecurity, study the existing applications and all. And we found out a uh, few missing features in the majority of the applications, and we thought of developing a web application with four major features, which are advanced differential scanning, WebSocket analysis, smart hidden endpoint detection, and also other vulnerabilities such as a SQL injection, cross-site request forgery, and all. So we developed this application using Go language at the back end and the front end using Vue.js. We thought of building it as a Go language script, and not using machine learning and all, because machine learning would take much computational power, and Go language is much simpler to implement. It's not visible. Just a minute. So the objectives of our project were to improve detection accuracy with less computation power, and evade modern security defenses, and also so analyze the strength of a firewall which is being implemented in the uh, web applications or websites which other users develop for their online platforms. And coming to the methodology we followed, we found out the security gaps in existing scanners, and we chose the Go language, the Gin and Collie packages within Go language, and used Vue.js for front-end interaction. So we built the project on by module, and we have code files each separately for advanced differential scanning, hidden endpoint detection, payload mutation, and WebSocket analysis. And after that, we have finally integrated them, and with using the REST API, we were able to get results when a user enters any URL in the front end and hit on scan. The Go language script would run and find out any vulnerabilities and report them back to the user. So we compared our application with OWASP Zap, Iron Wasp, Burp Suite, Akunetics, and others as well. We conducted the testing entirely on virtual platforms. We used Oracle VirtualBox, and the evaluation criteria was on the how fast the results came, how accurate the results, and how less of false positive were given, and also the resources used by the application while it was running. And these are the results which we obtained on the sites which we have performed our testing, and it is compared to other well-known scanners such as WhatsApp, Burp Suite, and Akunetics, and Arachne and all. So there are few gaps in our web application, which is not using AI or machine learning, and that's one of the setback, and it is when we built it only for, as of now, we built it only for small scale testing. We have to further scale it up to be used for enterprise grade applications and for on a larger scale. And also it is usually for web applications and only for English language websites. On so in the future we will definitely develop for multi-language support as well. And the impact of this is very good. And yeah, the detection accuracy was excellent. Upon, like, if you can see the results, we got a good amount of accuracy, and it can also be used for practice purposes for anyone. And we also are we also have plans to develop on a very full scale, and you use it further. Thank you.
Uh, Karthik, that's really very nice work.
Thank you,
So
sir.
do you know do you know the penetration testing?
Could you repeat that, please?
Penetration testing.
Yes, sir. We have an idea about it.
Okay, so how much is different from that?
What difference, sir?
Between a penetration testing and your this Volga tool?
Yes, I see. Our Vulgar tool also performs penetration testing, but we have
Mm-hmm.
automated, we have written a script so that the user only has to enter the URL of the website which they want to test.
But Karthik, in case of the SQL injection or XSS or any other kind of threat analysis, you need a payload as well. So not only the URL, you need to figure it out, what the input at what button you need it. So how you are going to test it? Or
In
are
the
you doing
script,
that kind of the testing?
so in the Go language code which we have, we
Mm-hmm.
included the payloads to try
Uh,
repeatedly.
but you just gave the URL only, right?
No, the user would input the URL and at the front end,
Mm-hmm.
and
Can you
and the
show me any demo if you have any running thing?
it's not in my laptop actually. My laptop
Okay.
is not very. I have a screen recording of it.
Can you just show me the quick?
Yeah, just a minute.
Mm.
And Karthik, also enable your webcam.
Yeah, just a minute, sir. I'm sharing this small
Mm-hmm.
execution video. Yeah, I'm playing
Okay.
it now. I'm playing it.
Mm-hmm.
the vulnerabilities are listed in the form like this.
Are you just running an open source code with a particular example?
Sorry,
Okay,
sir, I
it's
didn't
fine.
understand.
Okay, it's fine. You can include a few more things if you want to enhance it. You can include the third-party tools like a Black Duck, and
Okay,
there are some tools from the Synopsys and
okay,
SQL scanner that will help
okay,
you.
sir. Okay,
SSL
sir.
scanner. Yeah,
Okay, sir.
yeah. Best of luck.
Thank you. Thank you.
Yeah, I'm done.
I hope the question answer session is over. So thank you so much, Kartik Reddy. It was a very insightful session, and I really appreciate your efforts to put into the paperwork. Thank you so much. Now I would like to
Thank
call
you.
Mr. Ritesh Agwan with the paper ID 177, and the topic is Krushi Mitra, Machine Learning Based Smart Solutions for Crop Selection and Fertilizer Guidance. Please start your
Hello.
presentation.
Okay, ma'am. Okay, ma'am. I will share my screen. Everyone, can I start my presentation?
Yes, you can.
Okay. Our our presentation and our paper title was a
Please be
Krushi
a
Mitra.
little
Which,
louder.
yeah, our topic was an Krushi Mitra, a machine learning based smart solution for a crop selection and a fertilizer guidance. Where we in this my PPT, I have this much content where I covered the project definition, motivation, on what domain our project is, uh, what is the aim for creating this project, our project scope and methodology differences. The main problem was as our farmer uh, don't know what uh, fertilizer and what crop would give them more earning by giving
Ritesh
NPK value.
Agwan, sorry to interrupt, but your voice is not clear. Please speak near to the mic.
Hello, ma'am. Now it is coming.
Yes, fine.
Yes, it is audible, but put your PPT into presentation mode so that
Okay,
the
okay.
content is visible to all of us.
This is the problem where farmer faced, and for that problem, here is our solution. Where we got motivation from unpredictable unpredictability in agriculture, where agriculture which is highly sustainable, where weather, soil condition, demand fluctuations, where there is knowledge gap of profession advice of crop selection, what crop should be selected by NPK value, soil management and fertilizer user leads to reduce yield and waste, where the farmer don't know what fertilizer should they
put on the crop where they can grow much more crops, where there is resource constraint, empowering farmer with technology. That is our Krushi Mitra. Yeah, that is a bridge where the personalized crop and fertilizer recommendation we are providing. Uh, the gaps in the real-time project is IoT integration, limited region conversion, general fertilizer advice, and no disease severity detection. Uh, we have covered this gap through dataset, dynamic environment, not trial, and only basic identification. The motivation for this Krushi Mitra was a farmer, well, direct beneficiary who will use the platform. Uh, then the agrometric, agriculture consultants, government agencies, agriculture business. Our project works on this domain where we have integrated some about Python, React, APIs, and some about data set to give the prediction for the farmer. Our objective was about crop recommendation, fertilizer recommendation, real-time data integration, sustainability, farmer-friendly interface, Gemini integration, where we collected the data sets of weather data, soil data, and where we have processed the cleaning of that data, uh, where we have taken machine learning model for crop recommendation and fertilizer recommendation, where we have used logistic regression. The platform for this development is front end, back end. We have integrated API also. We have generated a testing of unit testing, integration testing, and user acceptance testing, and also performance testing. This is some out literature review, and this is reference. Thank you, sir.
Thank you, Ritesh. I would like to invite the session chair for question answer round and the participants too.
So Ritesh, here in the methodology, you mentioned the 4, 5 different steps.
Yes,
So which step actually you performed?
sir. We perform farmer.
Can you go? Can you go to a methodology?
Yeah,
Yes. Yeah.
yeah, yeah. We perform crop recommendation and fertilizer recommendation.
COP and fertilizer recommendation. So what was the input for that?
Yeah, we have taken NPK values, that is nitrogen, phosphorus, and potassium values. We have taken weather data, we have taken soil data, and then we have integrated API. API we have integrated because as a farmer who is using our platform, they can go through their own languages where API converts in their own language what the data is recommending to them. We perform a simple uh, algorithm here. When the farmer enter NPK values of his or his field, then our model goes to weather data, check the weather which is recommended for that region, then go to data sets and then recommend the crop which is favorable for that NPK values and that weather. And more often the fertilizer, our model also give which fertilizer is less for following crop you should means as an am farmer. I want to yield some watermelons and some about fertilizer is less, but I'm not getting what fertilizer is less in my field. So our fertilizer recommendation model gives you the proper fertilizer which is less in your field.
Okay. So last question is about the weather data and fertilizer recommendation.
Yeah,
Uh, those are the multi-year or just a 1 year data or the 1 day
sure.
data?
Yeah. I have to clarify here. Weather data is of 4 to 5 years,
Mm-hmm.
but but as government don't give us proper weather data. So we have
Mm-hmm.
integrated API, Gemini, where the Google has their own data set, their own real-time data set, which they can provide us the proper accuracy for the prediction.
Okay. Sure.
Ritesh,
Yes, yes,
I
ma'am.
have a question.
Okay, okay, ma'am.
So, I think this is an application which is going to suggest fertilizers and maybe crop according to the
Yeah,
soil quality, right?
yeah.
Because I could not see the whole presentation.
Hello, hello, ma'am. Pardon.
Already when we have applications like Kisan Suvidha by Ministry of Agriculture and IFCO Kisan Agriculture app, then why do we need your app?
Yeah, I will clarify
As a
here. The government app watch which they have, they do not recommend you what crop and what real time data and what real time crop should you predict. They do not do prediction, ma'am. They only suggest about the NPK value. We all added here the rainfall, the weather data, and also uh, and they
And
do
so,
not
so
recommend crop.
how you will be providing the weather updates? What is the technology that you will be using to collect that vast amount of weather prediction data
Yes,
so
ma'am.
that
I
there
have
is good accuracy?
yeah, I have told that we have integrated API of Gemini.
Hmm.
Uh, we know that Gemini is about the Google, and Google has the all real-time data. So the accuracy of APIs will be more rather than the data set we have. We have the less data set, so we have taken the API integration for the sake.
So this application will be used by the farmers by
Yeah,
themselves.
yeah. This application will be used by the
And
farmer.
is it user friendly?
Yes, yes, ma'am. It is user friendly.
Sometimes
It
the farmer
has
cannot read whatever you have written in English.
yeah, ma'am. I have told that our model works on three languages, main, that is Hindi, English, and Marathi. And
Mhm.
we have Hindi, English, and Marathi.
And does it has a voice search option also?
Not yet, ma'am. We can add it.
You can add to it.
Yeah, ma'am.
Okay. And are you trying to get in touch with the government sector
Yeah,
also so that you
yes,
can
ma'am.
update it
We
in a
we
better?
have mailed them. We have mailed them for all the data sets. As it is, they are not giving us the proper data set, so we have integrated the Gemini API for the same.
So have you tested your application? The
Yeah, ma'am. Yeah, ma'am. Yeah, as I am a farmer and I have tested it in my own field.
That's nice. So what was the accuracy? It predicted everything.
Uh, yeah, ma'am. Actually, now we have in the summer we have to yield some watermelons.
Mm.
We have given the NPK value to our data set. He have predicted what fertilizer is less in our field, and happy to say that we have put on that fertilizer, and we have yield more watermelons as earlier.
Okay, okay. That will be awesome.
Yes,
Thank you. Good work,
I
Ritesh.
can. Thank you, ma'am.
Thank you so much, Ritesh, for your informative presentation. I really appreciate your time and effort. Thank you so much.
Thank you.
Now I would like to invite Mr. Pranav Kumar, paper ID 276, with the topic Real-Time Steganographic Tool for Secure Data Transmission in Live Video Streams using AES Encryption. Please start with the presentation, sir.
Yeah, hello, ma'am. Yeah, let me share a screen. Is my screen visible? Hello.
Yes, it is visible.
Yeah. Good morning, everyone. My name is Pranav Kumar from MIT University. I'm here to present our research on real-time steganographic tool for secure data transmission in live video stream using AES encryption. This project was developed in collaboration with my team members, Rahul Ranjan, Devans Goyal, Gatyam Srinivas, and Bhupendra Sen. This is the outline. This presentation is structured into 7 sections. We'll begin with the introduction, followed by a literature review. Then I'll explain our methodology and system architecture. Next, we will explore the experimental setup and results. I'll also share a comparison with existing systems and finally conclude it with takeaways and future scope. In today's digital world, secure communication is not just about encryption, it is also concealing the very existence of message. While cryptography makes the data unreadable, I'll still signals that something sensitive is being transmitted, which can attract attackers. Steganography, on the other hand, hides the presence of message itself by embedding it into a media file like image or video. But existing steganography tool have like lots of limitations. Most rely on static images or pre-recorded video, and some don't work in real time and rarely combine strong encryption. So we build a tool that addresses these issues. It allows real-time hiding of AES encrypted messages in video streams, either recorded live or uploaded by the user. Moving to the literature review, we studied several prior work to understand the evolution of steganography. For instance, Peng's PhD thesis focused on dynamic steganography but didn't implement a practical system. Talking about Mahua's work, combined steganography with hybrid encryption but was tied to a specific protocol. And same with the Liang and Carr, integrated blockchain with streaming video, but their system was non-adaptive, embedding a lacked live recording support. Most tool lacked real-time capability, didn't support live input, or were not able to a non-technical user. Our tool solved these gaps and focused on real-world usability, a strong encryption, and low processing time. Moving to the methodology, we developed the tool using Python and several open source libraries of it, like OpenCV, MoviePy, NumPy, cryptography. Also, we have implemented for AES 128 encryption, HashLive for SHA 256. Hashing is implemented just to verify the integrity. The workflow starts with the user entering a secret message and selecting a video. The message is encrypted using AES, converted into binary bit and embedded into list significant bit LSB in the video frames. Moving to the next slide, system architecture. This diagram explains the entire flow. The user input a message and either upload or record a video on the right. AES encryption is applied to the message using OpenCV. We extract video frames, then each bit of the encrypted message is embedded in a list significant bit of the pixel values. Finally, the video is reconstructed using MoviePy and made available for download. The tool also has both CLI and GUI interface to cater to the different type of users. Moving to the next slide. Embedding mechanism. The core embedding algorithm works like this. Each encrypted message bit is stored in the least significant bit of an RGB pixel. This is done across frames, ensuring high capacity and minimal distortion. Optimization includes NumPy vectorization, skipping high motion frames. Moving to the next slide. Experimental setup. Our tool was tested on Ubuntu 22.04 with an Intel i7 processor and 16 GB RAM. We used Python 3.10 and library OpenCV 4.7 and MoviePy 1.0.3. We tested across various video models and settings. If we talk about resolution like 480p, 720, also we tried on 180, sorry, 1080p. Duration we have tried on 5 second, 15 and 30 second. In both the way, uploaded and live recorded videos. Moving to the next slide. If we talk about result and performance and accuracy, the result showed excellent performance. Embedding time was fast, only 2.7 second on an average for 720p uploaded videos. Memory usage was efficient even at 1080p. PSNR was consistently above 40 dB, indicating minimal visual difference. SSIM was above 0.98, confirming a very high image fidelity. Message retrieval accuracy was near 100% even for a long videos when we were uploading it. Additionally, latency and throughput were optimal for real-time communication. Moving to the next slide. If we compare it with existing systems, just a second. Sorry. Uh, Compared to the previous system, our tool offers significant advantages like real-time embedding is supported. We used AES 128 encryption for better confidentiality. We support both uploaded and live input. Our GUI makes it easier for non-tech users also. We outperform other than PSNR, SSIM, and retrieval accuracy. You can check the radar on the right side. It clearly shows our tool's well-rounded performance. Moving to the next one. Coming to the conclusion, we successfully designed a real-time encrypted video steganography tool that hides messages without visibility affecting the video. It supports live and uploaded video, maintains high visual quality, and offer almost 100% accurate retrieval. This tool can be highly useful in fields like military communication, whistleblower performs, secure field reports. And if we talk about future enhancement, AI-based adaptive frame selection can be added, support for audio steganography we can add, and mobile deployment we can add. If we talk about reference, these are some key references we cited in our research. Thank you so much for your time and attention. Now I welcome for any questions if you may have.
Parnav, this is really very good project. So you mentioned couple of things here. So can you share where you are storing a hashing value?
Sir, currently I don't have the codes, but I have some images. Sorry.
No, I'm just asking, you mentioned in the pixel, in the LSP, you store
Yeah.
the bit by bit,
Yes, sir.
right? And in the initial, you mentioned that you are also taking a hashing to make
Yes, sir.
sure, whatever you're sending is matching with the hashing. So where that hash is going in the video?
Sir, actually, we are using for hashing like we implemented cryptography, AES encryption.
Uh, that's right, AES encryption.
Yes, sir.
AES encryption provide you the encrypted value, right? But at the
Yes, sir.
same
Yes, sir.
time, you are storing the hashing value as well.
Yes, sir. I understood. Actually, for like hashing the store, we do not store the SHA-256 hash inside the video. Instead, we compute the hash of the original message before like embedding it, and optionally store or display it separately for the user. I think it is good.
Okay, if in case if any frame is missing, right?
Yes, sir. Yes, sir.
Or there is a spoofing happened in any of the frame, how you are make sure integrity of the video is right.
Yeah, for yes, sir. I understood.
And
During
and also And also during a transmission time, sometime, the network do its own optimization and it can drop some frame, right? So how you're achieving the
Sir, for this, like during retrieval, the extracted message is hashed again. And if it is matched the original hash, we know the message was not tampered. This provide integrity verification, we can say. But we leave it to the
um
user whether they want to save or transmit the hash externally. Yeah.
okay, that's fair enough. Another thing is at the end user, are you
Yeah, yeah.
providing any tool to, retrieve the
Sir, as I
encrypted
mentioned, we have.
message?
Yes, sir. Yes, sir. As I said, we have implemented for created it for non-tech user also. So we have made a GUI. So on the same
Mm-hmm.
platform, there is option to retrieve. Like they can normally
Mm-hmm.
upload the same thing which is encrypted, and they will get the things which is hidden in the video or image or live video, whatever.
Okay. Okay. No, this is a good one. So my
Yes.
suggestion is you can do a little enhance on this.
Yeah, sure, sir.
Like so enhancement could be, the retransmission of certain frame uh with the same value, just to make sure if any frame is dropped, you still recover the message.
Sure, sir.
Right?
I'll do it, sir. Yeah.
Right. Another thing is for AES 128. You are using a 128 encryption, right? Or
Yeah.
256? 128.
Uh, yeah, AES 128, and for integrity, we are using SHA 256.
Yeah, so instead of that, you can use the 1024 AES because
Yeah,
AES 128 is not secured. It can
yeah.
be break.
Incompatible. Yes, sir.
Yes.
Sure,
Okay.
sir.
Yeah, thank
I'll
you so
implement that.
much.
Thank you
Yeah,
so
thank
much,
you
sir.
so
Yeah,
much. Best of luck.
thank you.
Thank you. Thank you so much, Pranav. We really appreciate your effort. Thank you. Now I would like to call Mr. Aryan Singh with the paper ID 20, and the topic is early detection of student dropout risk via hybrid deep learning and gradient boosting algorithms. Please start presenting your paper.
Am I audible?
Yeah, you are.
Okay, I'll be sharing the screen now. Is this visible?
Yes.
Yes.
All right. Good morning, ladies and gentlemen. I am Aryan Singh, and I, along with Vaibhav Rajput, am pleased to present our work titled Early Detection of Student Dropout Risk via Hybrid Deep Learning and Gradient Boosting Algorithms, which we conducted under the guidance of Dr. Subhash Chand Gupta. This research is rooted in a growing challenge, student dropout in online and higher education settings. We aim to proactively identify students at risk using an innovative combination of deep learning and gradient boosting, achieving not just high accuracy, but also meaningful insights. So, the transition to online and hybrid learning, while flexible, has led to the rising dropout rates, particularly in the massive open online course (MOOCs) and the higher education institutions. Traditional systems fail to act early enough. Well, our solution, a predictive model that learns from historical student data, academic, demographic, and financial, and flag those likely to drop out well in advance. This helps educators intervene early, saving careers and institutional resources. Moving on to the case study, we have two primary case studies. Our research incorporates two real-world case studies. Our one focuses on predicting student disengagement using past performance and activity logs. The second tracks academic performance over time to offer timely academic support. Together, these case studies help us train models that are not just accurate but also practically useful in real-world educational settings. So now moving on to the methodology overview. Our methodology is a two-tiered hybrid model. Step one, a deep neural network, a DNN, extracts high-level patterns from complex student data, capturing abstract features such as latent motivation and engagement. Step 2, these deep features are then passed into the gradient boosting model like XGBoost, which we have used, which excels at fine-tuning predictions on tabular data. This hybrid architecture combines the pattern recognition strength of our deep learning with the precision of gradient boosting, making our approach more advanced than traditional single model methods. Now moving on to the model performance comparison. We evaluated a hybrid model against 5 other popular machine learning algorithms: logistic regression, decision tree, random forest, SVM, deep learning alone. Our hybrid model alone outperformed all of them, particularly in metrics like AOC ROC achieving a 0.95, which is a 95%, which indicates excellent classification. It was particularly effective at minimizing false negatives and false positives, crucially when trying to save at-risk students. Why is our model, ROC analysis? Here you can see the ROC curve of our best model. The curve hugging the top left corner reflects a high true positive rate and low false positive ratio. That means when we say a student at risk, we are usually right and we rarely sound a false alarm. That level of accuracy is game changing for institutional decision making. Why? Now you may think, why is our model more advanced and how is it different? What sets our work apart from existing literature? Well, first of all, hybrid design. A few more models combine deep learning with gradient boosting and dropout prediction. The second one is interpretability. We use SHAP values to explain which features derive prediction. SHAP values which we treat as players and which always contribute to basically making our project effective, and every feature is treated as a player and are taken into consideration. Feature richness. Our model considers demographic, financial status, parental education, past education performance, and even attendance. Real world deployment potential designed to run in real time on school dashboards. In conclusion, dropouts don't happen suddenly. They leave clues. Our hybrid model detects those clues early with high accuracy and interpretability. It empowers institutions to take action before it's too late by reaching out to students who need the help most. We believe this work has potential to transform academic retention strategies across institutions. These are all the references we have used. We have built on robust research in education analytics, machine learning, and neural networks. Our work synthesizes best practices and pushes them further into the real world. Before I conclude, I would also like to express my heartfelt thanks to my family, and especially my co-author, Mr. Vaibhav Rajput, for their unwavering support throughout the research journey. Their encouragement gave me the strength to stay focused and push through the challenges of the project. Thank you to my guides, Dr. Subhash Chand Gupta, and the organizing committee for giving us the platform to present our work. Thank you for all the attention. I'd be open to take any questions now.
Aryan, thank you so much to present it. It's really nice work. So did you made any real world application where you can pass some input?
Yes, sir. We actually used a data set from ULAD and Harvard, and then we created our own small website. But currently, it's still in development stage. It's not fully ready. That's why.
Okay. Another thing is what kind of the input you need in the real world scenario.
So we have basically chosen elements which fall under enrollment age, sex, marital status, family size, past qualification, course of study, daytime and evening attendance, mother's qualification, father's qualifications, displaced, instructional special needs, debtor, scholarship holder, curriculum units first sem, curricular units first sem, evaluations, curriculum units first sem approved, and other things. And soon we'll be also incorporating psychological metrics also in this.
So how many year of data do you need to correctly predict the behavior?
So currently around we have used 21, we have used 17 data sets, basically 17 features to predict. And we have used over 15,000 students from ULAD and Harvard currently.
Okay.
So how can you decide, Aryan, these 17 variables just help out you to provide you the accurate result?
So because we have
Correct.
sorry, sir. So basically, we have
Please,
also checked out in the real-time scenarios also. So first, we use the old-time data, which was from 2018 and 2019, which was on ULAD and Harvard. We use those data sets to compute our own program. Then we check those results with the real world and what actually happened with those students. And that gave us the clarity. And also our AOC and ROC accuracy was 0.95, which is really high. Like before the past, whatever past models were used, our gradient boosting has really upscaled the prediction percentage.
Have you incorporate any variable in difference of Indian environment or Indian student? Because if you
Yes, sir.
take something which is from outside of this country, so that is that influence of that particular data or their nature and their
Yes,
culture.
sir. We have also taken a few, like as I said, family size qualifications, father's qualification, displays, instruction, special needs, curriculum for SEM. Financial status is particularly taken in this, and we'll also be incorporating uh, psychological data sets as well and metrics to use for the Indian environment as well in an Indian setting.
Broadly, what you want through your experiment or through your this created model.
So I
If
could,
I'm just asking you as a broader output, what exactly you're finding?
so we're basically predicting the dropout rates, and we're basically helping the institution to help those children who tend to drop out or tend to fail in some subjects or tend to have a few background problems that we don't know of. The institution knows, so the institution knows better about the student, and basically every student has a clue, and we catch those clues in order to interpret our data and in order to give an accurate result so that the institution can help them.
Because dropout problem is associated in every institute or in any school. So anything, I just because I'm just curious to know through you
Yes.
what different finding you if you executing your own data set. So something which is very much different, and if you would you like to share with us? If this is the
So,
reason of dropping that particular course or something.
so the difference would be the psychological metrics, which we are currently in the undermaking. It is still going on, and we have started meeting up with the few psychologists to use the data as well, which would be very different. So we would be their mental capacity.
Okay. Thank you from my side.
Thank you so much, sir.
Thank you so much, Aryan. We appreciate your time and effort in presenting such a thought-provoking paper. Thank you so much.
Thank you so much, ma'am.
Now, I would like to call paper ID 188, Mr. Salim Aslami, with the topic Enhancing Organizational Performance through the Application of AI in Performance Management System. Please start presenting the paper, sir.
Thank you, madam. Am I audible?
Yes, your order.
Okay, madam. Let me share my screen.
Hello. Excuse me, ma'am. I am Dharm Singh. Ma'am, I think my name was called, but I was not there because of a network issue.
Oh, no, your name wasn't called. You're after this presentation, sir.
Okay, okay. Thank you, ma'am.
Madam, can you see my screen?
Yes, it is visible. You can start.
Okay, madam. Madam, so thank you for giving us the opportunity to share our work with this team panel. So our topic was enhancing the organizational performance through the application of AI in the performance management system. So the co-authors were the Miss Nidhi Natarajan, Rinko Sanjeev, and myself, Muhammad Salim Aslami. And our outline includes the introduction part, the review of the literature, the methodology, and then the discussions and conclusions. So in introduction, the first will start with the context and motivation for the AI, embedded performance management. So artificial intelligence is significantly transforming the human resources functions. It automates tasks, enhances decision-making, and improves employee engagement. Uh, as per our findings, the adoption of the AI, now the 92% of the companies plan to expand their AI investments within the next 3 years, as per McKinsey. The problem statement that traditional performance management systems are usually limited to subjectivity, inefficiency, and inconsistency in evaluations. These are the three main limitations of the traditional performance systems. And there is a need for What employees really want is the real-time feedback, the data-driven feedback, and the adaptive performance assessment mechanisms. Our objectives for this work was to investigate the moderating role of AI in enhancing the relationship between performance management components that includes the four stages, the goal setting, the uh, performance feedbacks, the performance appraisals, and the rewards with the organizational performance. And the significance of this study includes that AI-enabled performance management systems supports predictive analytics, continuous feedback, and unbiased decision making. It also contributes to the developing of high-performance, agile, and inclusive organizational cultures. In the review of literature section, AI enhances the real-time performance monitoring, predictive insights, and continuous evaluations. It also enables dynamic alignment of the employee goals with the organizational priorities. The key components of the performance management that can be enhanced by AI includes the goal setting phase. AI replaces subjective planning with data-driven and adaptive goals. It also results in 35% productivity improvements as per Gartner 2023. Performance appraisals. In this stage, the AI shifts from biased periodic reviews to subjective and real-time assessments. It also improves the accuracy by 40% as per Deloitte. In the feedback section, it utilizes the natural language processing and sentiment analysis for instant and unbiased feedback. It also enhances or increases the employee engagement, and it rose to 50% as per the McKinsey. In the reward systems, AI ensures transparent, equitable recognition based on performance matrices. It also boosts retention by 20% as per the PwC reports 2023. In the methodology section, we'll be discussing on the sampling and data collections. So 150 valid responses were collected from senior HR professionals across 5 organizations, 50 from each one. All respondents had experience with AI-enabled performance management systems. And the analytical approach, we used the partial least square structural equation model, suitable for complex models and testing moderating effects of AI. In our study, the independent variables were the components of the performance management system that includes the goal setting, the performance appraisals, the feedback mechanisms, and the reward systems. And the dependent variable was the organizational performance. In the takeaway section, the study confirms that the critical moderating role of AI in enhancing performance. AI significantly improves the goal setting, performance appraisal, and feedback mechanism, driving data-driven and dynamic HR practices. The AI embedment has limited impact on it. It was observed that it has limited impact on a reward system due to subjectivity and human-centric elements. The implications of the study: AI adoption in HR can lead to greater objectivity, real-time insights, and enhanced organizational performance. Organizations must combine AI tools with human judgment, especially in reward and recognition systems. And the future research direction, we would like that it should be expanded. This study should be expanded to more organization and drive industry and diverse industries. Examine influence of leadership styles, change management, and the organizational structure, organizational culture that we have not included. And also, we should explore, or the writers should explore the ethical concerns, the data privacy, and the AI governance in the HR analytics. So thank you so much. And thank you again for listening to our work and the presentation. And now we are open for questions, if any.
That is really a very good work. So you mentioned you collect the data from certain organization, from the five different organization. What kind of the industry
Uh,
that organization are from?
yeah, the data was collected from Starbucks, the
Uh-huh.
Burberry, the McDonald's,
Uh-huh.
the Spotify, and the North Face.
But there are some data, I mean, all company are in the different domain,
Yeah, because
right?
sir,
Spotify,
yes, sir.
is
Our focus
Spotify
was.
different?
I totally agree. So our focus was to collect data from those organizations that are, as per our understanding, they were familiar with using the AI embedment in their performance systems. So we shortlisted these five organizations.
Um, in your presentation, you also mentioned that it should incorporate the change management leadership, right? So this kind of the thing depend upon the management style and what kind of the industry that company is. So if you are taking from the five different, how you are, make sure it will work for your own thing.
Sir, if you allow, if I may also, he has written a paper with us along with his guide and me. So if you
Mhm.
allow me, I would like to add some points over here.
Please go ahead.
Yeah. So this topic that he has chosen is a smaller part of a bigger, work that he is doing because his thesis is also based upon the performance. And from that, since his main work is in Afghanistan, so as of now, he has taken a purposive sampling where the secondary data indicates that these companies have somehow, successfully at least started using AI because in his country, as of now, still this usage is in the progressing stage, and he cannot find any company with the implementation to check whether it was successful or not.
Mhm.
So that is why he has taken a purposive sampling where the secondary data certifies that the participant from these company would be able to come under the scope of these questions. Otherwise this will not apply to everyone.
Right. No, fair enough. And only my last question is a replacement for the PMS or is just additional, it's providing additional support to the PMS?
Sir, it will not be replacing PMS, but rather it will be enhancing the PMS function.
Okay, sure. Yeah, thank you so much and best of luck.
Thank you, sir.
Thank you,
Thank
sir.
you.
Thank you so much, Mr. Salim Islami. Thank you for sharing your expertise with us.
Thank you, madam, for the opportunity given. Thank you.
Now I would like to invite Ms. Harshita Moga, paper ID 207, with the topic Assessment Disparities in MOOCS, a data-driven study.
Hello, good afternoon, everyone. Am I audible?
Yes, please be a little louder.
Is it audible now?
Yeah, clear.
Okay. Is my screen visible?
Yes.
Thank you. Good afternoon, everyone. My name is Harshita Mukha, and I'm currently pursuing my BTech from MIT University, Uttar Pradesh. Today, I have the honor of presenting a research titled Assessment Disparities in MOOCs, a data-driven study co-authored with Dr. Natasha Steele, Hassan Kamal, Dr. K.M. Soni, and Isra Imtiaz. This work reflects a deep interest in understanding learner diversity in online education, and that impacts assessment outcomes. Okay, so moving on. Well, MOOCs, basically massive open online courses, have become a hallmark of digital learning in the 21st century. They are accessible, flexible, often free, and open to anyone with an internet connection. Platforms like Coursera, EDX, NPTEL have enabled millions of millions of learners to learn new skills from top institutions worldwide. But while MOOCs promote educational inclusion, we ask ourselves, are all learners benefiting equally? Or do students from technical and non-technical backgrounds perform differently in these MOOCs? And if yes, what patterns can we uncover using data? That was the driving motivation behind the study. So the objective, these are the table of contents that we're covering in this presentation. Okay, so coming on to the objective. Our goal was to examine performance disparities between technical and non-technical domain students in MOOCs. To ensure diversity, we selected two distinct courses. They both are NPTEL MOOC courses. Python for data science, that is a technical course that requires logic and programming. And meanwhile, the other one is effective writing, a non-technical course focused on communication and language. We assessed performance across two key dimensions, like internal assignments, which reflects ongoing engagement throughout the course. And then there is proctored exams, which test final understanding under supervision. So to uncover deeper insights, we used K-means clustering, a machine learning technique to group students based on score similarities. Literature background, we grounded our research with a Prisma-based literature review. Out of more than 1,000 studies, we shortlisted 20 high-quality peer-reviewed papers for detailed analysis. Several key patterns emerged, student success is linked to active engagement, like video views and discussion participation. Consistent performance in formative task contributes to final outcome of the proctored exam. Yet surprisingly, most studies gave limited attention to internal assessments, and even fewer explored performance differences between technical and non-technical learners. That's where we saw a clear research opportunity. Here is the Prisma diagram, which shows the how we outline the papers we read and shortcut to the 20 final studies we used in our literature review. Okay. While we did the literature review, previous studies have done an excellent job exploring overall performance in MOOCs or analyzing dropout rates and engagement patterns. However, what's missing is a comparative lens, a way to see how background discipline influence assessment performance, especially when we separate internal scores from final proctored exams. Our research fills the gap by offering both quantitative statistics and cluster-based visual analysis to show how students from different academic domains perform. Methodology overview. Our methodology involved four main steps. Data preparation, we cleaned the data set, the two courses we took, we cleaned the data set, removed the outliers, and standardized the scores. There was a significant difference between the technical and non-technical data sets. So we normalized it using min-max normalization. It basically scales each score to find a range, typically between 0 and 1. So we categorized the student. Learners were grouped into technical students and non-technical students. And then we did the assessment mapping. We extracted the internal and proctored scores, which was available in the data set itself. Then we used the k-means clustering while we perform. This was applied to detect like the natural groupings based on assessment scores, revealing performance trends across categories. The methodology allowed us to move beyond averages and see patterns across thousands of learners. So coming on to the first course we took, effective writing, that is a non-technical MOOC course. In the effective writing course, we analyzed around 4,363 students, and out of which 656 were from technical backgrounds and 3,707 were from non-technical ones, which had a huge difference. So we normalized it again. Here are the results, like internal scores, technical, the average that came around is 19.53 and non-technical 18.82 out of 25. And then proctored 50.22 in technical, and for non-technical it was 46.44. What stood out is that although technical students were in the minority, they showed slightly stronger average performance in both assessment types. Rather than suggesting superiority, this reflects how factors like previous exposure to structured assessments, familiarity with online platforms, or analytical skills might influence outcomes even in non-technical courses. Then this this is the cluster visualization. This is a scatter plot which displays internal versus proctored scores, with blue dots representing technical students and red dots representing non-technical students. While this isn't the final cluster output, it reflects the underlying distribution before applying k-means. We observed a concentration of red dots in the mid-score range and more blue dots trending towards the higher spectrum. This reinforces our hypothesis. Learner background plays a role in shaping assessment patterns, even when the subject is non-technical. Coming on to the technical MOOC course that we took, that is Python for data science. It had a total of 2,321 students, 2,214 from technical domain and 107 from non-technical domain. Again, a huge difference. We normalized it. The key observation that we made were internal scores. Non-technical students slightly outperformed. Proctored score, technical students had a clear edge. They scored more than the non-technical ones. This tells us that non-technical learners may engage actively in assignments, but could face challenge in time-bound, logic-heavy proctored exams, possibly due to unfamiliarity with programming assessments. So here's the score distribution for the Python course. Again, blue dots indicating technical learners and red dots representing non-technical learners. You can clearly see that the red dots are sparse and mostly in the mid-range, while blue dots dominate the upper half. Even without drawing cluster boundaries, the performance disparity is evident. The visual powerfully supports the statistical findings. Then, to validate our observation, we conducted t-test and calculated Pearson correlation coefficients to compare the performance of technical and non-technical students in both MOOCs. The t-test helps us check if the difference in score between the two groups and are statistically significant or not. In effective writing, as we can see, the internal p-value came out to be 0.00896. This is below 0.05, meaning the internal score difference between tech and non-tech students is statistically significant. While the proctored p-value came out to be 3.23 into 10 to the power minus 27, extremely low, confirming a very strong difference in proctored performance. Similarly, we had in Python for data science, it was slightly above the 0.05 threshold. suggesting the difference isn't strong enough to be significant. And for Python p-values, we had again highly significant, showing a clear performance gap in final exams. Then we also calculated the Pearson correlation. We checked how closely internal and proctored scores are related using Pearson correlation. For technical students, the correlation ranged from 0.15 to 0.28, while for non-technical students, it was stronger, 0.20 to 0.32. This means like for non-technical background learners, internal performance is more predictive of how they'll do in the final exam. So these statistical values confirm that while both groups showed differences, proctored assessments reveal the most significant disparities, and internal scores are especially important for tracking learner progress. So to summarize, students from technical backgrounds performed better overall, particularly in proctored exams. Internal scores are useful rather than, uh, sorry, they are very useful, like internal score are useful early interventions, especially for non-technical students. Okay, so course, it highlights the need for personalized impact on courses and support. Non-technical learners may need foundational resources in technical MOOCs. Course designers should integrate formative assessments with timely feedback, and adaptive learning tools could tailor content based on learner progress and background. These strategies can help bridge performance gaps and support more equitable outcomes. Final thoughts and future work. MOOCs hold incredible potential, but one size does not fit all. As educators and technology, we must ask, like, are we designing the courses that adapts to learners, or asking learners to adapt the course? Future research will be basically, we'll be incorporating behavioral data like video engagement, forum activities, and we might include socio-demographic profiling and test adaptive teaching strategies to personalize the learning journey for all types of students, irrespective of the domain they're following. So thank you so much. This is the end of the presentation. I would like any questions you may have.
Um, Thank you, Ashita. This is really nice work. Um, so for the sample part, from where you get that data, you had a quite
So
good sample.
yeah, so actually we took like two MOOC courses, and both of these courses were taken from a first-hand like academic partner for research purposes with anonymous identification. Like I can't reveal the actual source, uh,
Mm-hmm.
but it was through the mentors that was guiding us through this research.
Okay, right. So also you mentioned about the future work,
Yeah.
right? So are you also working on that part or?
We've just started. We've also come up with a solution, like a platform, just like Coursera and EDX. We're thinking of developing a application which is based on students, capabilities. Like if they're enrolling in a course, we'll probably take the pre-training assessment to evaluate where the actual level of concepts they know already. And if they're low, so we can provide them with the tutorials and like mid-value feedbacks for all the students, irrespective of the background domain. For example, if a non-technical background student enrolls in a course with programming and stuff, like for Python for data science example, so we'll probably assess the student first and provide them with tailoring content, which will cater to the level of understanding they have for the particular course, and further enhance their level as they move on with the course.
Okay. Yeah. No, thank you so much. Best of luck.
Thank you so much.
Thank you so much, Harshita. Thank you for your valuable contribution to our discussion. Now I would like to call Mr. Dharam Singh, paper ID 156, with the topic Secrecy Rate Optimization for MIMO Communication Radar System employing Cuckoo Search Algorithm.
Good
Please
afternoon,
open
ma'am.
your camera.
Yes, ma'am.
Your screen is visible, but you are not visible.
Am I audible and visible now?
You are audible, but you aren't visible. Your screen is visible.
Okay, one second, please.
Turn on your camera also.
Now I'm visible.
Okay, please continue.
Ma'am, 1 minute, please. Now I'm audible and visible.
Yes, you are. You may continue.
Okay. Thank you for the opportunity. Good morning, good afternoon, respected dignitaries, estimated researchers, and fellow participants. It gives me immense pleasure to welcome you all in the International Conference on Engineering, Technology, and Management. I am Dharam Singh, and today I will be presenting on research on secrecy rate optimization for MIMO radar system employing Cuckoo search algorithm, conducted in collaboration with Dr. Resha Mehrotra, Dr. Silpi Bist, Dr. Sachin Kumar, and Anant Kumar. Our work focuses on addressing non-convex optimization challenges in MIMO radar system secrecy rate using Cuckoo search algorithm. We have employed Levy flight dynamic in our algorithm and successfully achieved a secrecy rate between 68.34 and 130.14, outperforming traditional optimization methods by about 15.7%. Wireless communication systems are inherently vulnerable to security threats, especially eavesdropping. To address this, physical layer security has emerged as a promising approach, focusing on signal level protection rather than just encryption. MIMO radar system offer multiple benefits, including spatial diversity, robustness against interference, unintended signal leakage, and greater control over transmitted signal. However, due to the openness of wireless media, interception by unauthorized users remain a major concern. This study explores how we can use intelligent optimization to maximize secrecy rate at physical layer. Before diving deeper into our optimization strategy, let's take a moment to understand the fundamental metrics we are trying to optimize. It's a secrecy rate denoted by RS. The first term, as you can see on the screen, the first term represents the data rate at a legitimate receiver, and the second term captures the rate towards the intended target in the radar system. And the final part, which estimates the total capacity that potential eavesdropper could achieve. Now let's now let's talk about the optimization challenges at the heart of our research. The goal in our system is to maximize the secrecy rate, which, as you might expect, involves a lot of variables and constraints. But here's the problem. The function we are trying to optimize is non-convex, meaning it does not have a clear optimum. Instead, the solution space has many peaks and valleys, and traditional techniques like convex optimization or gradient-based methods often get stuck in a local optimum. That's why we shift towards the cuckoo search algorithm, known for its global search capabilities. The cuckoo search algorithm is inspired by brood parasitism behavior of some cuckoo species. Cuckoo species, that is a bird. It works by replacing poorer solutions with new, better ones, just like cuckoo lay eggs in the nest of other birds. It uses levy flight, which combines short steps, which occasionally with occasionally long jumps, allowing it to explore the search space efficiently. It also employs nest abandonment, which encourages local refinement. This balance between exploration and exploitation is ideal for solving our problem. This is the problem that we have tried to solve. We applied our approach to the radar communication system with 10 transmit antennas, 5 legitimate receivers, and varying number of eavesdroppers. This real-world simulation allowed us to test the algorithm in a dynamically changing environment. Here's how the algorithm works step by step. We begin and start with a random candidate solution or a nest. Measure the quality of each solution using the fitness function, which in our case is the secrecy rate, which we have tried to maximize. Generate a new candidate solution using levy flight, replace the worst solutions with better ones, always preserve the best candidate. This iterative process continue until we converge to an optimal solution. This slide presents the quantitative comparison between our proposed cuckoo search algorithm and the traditional optimization method for secrecy rate performance in MIMO radar system across different number of eavesdropper antennas. The first column, as we can see, shows the number of eavesdropper increasing from 5 to 30. The second column shows the secrecy rate achieved by our cuckoo search algorithm approach. If you look at the third column, which shows the performance of the traditional method. This comparison clearly highlights two key points. One method, our method is not only more effective, but also scales well as the threat level increases. Traditional methods, while simpler, lack adaptability and fails to leverage the full potential of MIMO's spectral diversity. This is the graph which shows the secrecy rate across various configurations. The rising curve demonstrates how well the cuckoo search algorithm adapts to increasing eavesdropper complexity. It clearly outperforms traditional algorithm, proving its robustness and efficiency. This slide presents the computational time complexity associated with our algorithm as the number of eavesdropper antennas denoted by NE increases. In terms of advantages, our algorithm achieved up to 15.7% improvement, handled non-convexity well, and required minimal parameter tuning. On the downside, it has a higher computational cost, but this is expected with meta-heuristics. The practical applications of this work span multiple domains: secure military communication, security in 5G network, automotive radar system, and various surveillance networks. Our research offers a strong foundation for deploying secure wireless technology. In conclusion, the cuckoo search algorithm successfully solved the non-convex optimization problem of maximizing secrecy rate in MIMO system. For future work, we propose exploring hybrid models combining cuckoo search algorithm with PSO, that is particle swarm optimization, and genetic algorithms to further enhance performance. Before I end, I would like to thank all my co-authors and institutions who supported this research. This work would not have been possible without their valuable insight and collaboration. Thank you all for your time and attention. It's been an honor to share our work with ICETM, and I would be happy to take any question or feedback from the audience. Thank you.
Dharam, I have a question. What inspired you to work on this project?
Sir, as we can see, sir, we all are transmitting data from here and there, and
So do you have the hardware or how you are getting the data as well?
sir, this is the comparison, or we can say, I have just applied cuckoo search algorithm on a problem and achieved better results than the traditional method.
So from where you get that data?
Sir, I have taken this data from one of the base paper.
And how you can test it?
Sir, I have taken the problem from the base paper and applied a different algorithm, that is cuckoo search algorithm, and after that I get the better results than the traditional ones.
But test कैसे किया?
Sir,
Is performing a better than the previous one. So how you
sir,
tested it?
we have find a different results at different eavesdropper. Sir, we have taken the problem from that paper and compared the results from that paper. So we have find the better results, and secrecy rate. We have tried to maximize the secrecy rate and compare.
And how you define the secrecy rate?
Sir, it is the rate at which, sir, rate at which, sir, we try to, sir, suppose you are trying to share some data to intended receiver, and in between there is one unauthorized or unintended receiver which is trying to stole that your data from, or it is creating trouble in sharing your data.
Okay. Yeah. Thank you, Dharam.
Thank you, sir.
Dharam Singh, you have talked about time complexity. What do you understand by time complexity? It is in your presentation.
Yes, ma'am.
What do you understand by time complexity? Do you understand the term?
Yes, ma'am. Time complexity. I understand.
So
Ma'am,
please.
it is a as we can see, that as the number of eavesdropper increasing, how many iterations it will means for how many iterations it will run. That is the time complexity. How much time, extra time it will take. That is time complexity.
Okay. Do you think of any other search algorithm? You have applied cuckoo search algorithm. Do you think of any other search algorithm that you can apply in your research?
Yes, ma'am.
That can give better results.
Yes, ma'am. As I have mentioned that my future work will be that I will use the particle swarm optimization or hybrid algorithm with cuckoo search algorithm and particle swarm optimization. So after that, I can say that it will be better or something.
Thank you so much, Dharam Singh.
Thank you, ma'am.
Thank you so much, Mr. Dharm Singh. Your presentation was a highlight of our event, I would say. Thank you for your time to share your research with us. Now, I would like to call Mr. Abhijit Gurudev Khare, paper ID 375, with the topic Exploring the Intersection of Artificial Intelligence and Mental Health, Data-Driven Approaches.
Am I visible?
Yeah, you're
Am I
on.
audible? Sorry. So, good afternoon, everyone. My name is Abhijit, and today I would like to present my research on the intersection of AI and as it is advancement age of AI, and also the intersection of mental health, which is a growing cause of trouble in college students and also working professionals, right? So, also I would like to first of all thank Amity University for upholding this conference and giving me the opportunity to present my work. Should I share the PPT? Share the PPT with a second. Hold a second, please. Sorry. Yeah. Is it visible? Okay, wait a second.
I think due to some technical issue has left the meeting. Let's wait for him. Until then, I would like to invite Mr. Rachela, the paper ID 224, with the topic comparative analysis of CNN and KNN for blood group detection using fingerprint images. Are you ready?
Yeah, good afternoon.
Please start, sir.
Am I audible?
Yes.
Okay. Can you see my screen?
Yes.
Good afternoon, everyone. My name is Racharla Chendu. I'm currently pursuing BTech fourth year from Lovely Professional University. Authors are Racharla Chendu, Chiraboyina Jayaraju, Amar Narayana, Padala Ramu, and my professors are who helped us in this project is Abhinav Singh and Komal Arora. Like project is comparative analysis of CNN and KNN for blood group detection using fingerprint images. For this introduction is like blood group detection is a critical component in a medical diagnosis, emergency treatment, and blood transfusing processes. Like we have traditional methods really on like surgical testing, which while accurate, but it can take a lots of time to like give the result. So for this, like in recent years, biometric-based identification techniques have gained traction as a non-invasive and efficient alternatives. Among these, fingerprint biometrics offers a unique and consistent patterns for each individuals like making them an ideal candidate for exploring novel physiology correlations such as blood group detection. And yeah, I used KNN and CNN. So I compared KNN and CNN for this project. So like I got less accuracy using KNN. So I changed it to CNN. So CNN can has recognizing special features like compared to KNN. This is the introduction, like blood groups and for fingerprints, critical nature for of blood groups. Like we have 8 different kinds of blood groups: A positive, A negative, B positive, B negative, AB, and O positive and O negative. Challenges with current methods, like traditional blood group detection techniques are invasive, requiring blood samples and special labs, causing delays. And here is the literature reviews of CNN and KNN in biometrics. Like CNN, convolutional neural network. CNN excels in image recognition by automatically extracting complex features. They are the backbone of facial recognition and object detection systems, delivering state-of-art result in image classification. And KNN, K nearest neighbors. KNN is a simple and powerful classification approach that assigns classes based on the closest data points in feature spaces. It has been efficiently applied in iris and voice recognition tasks. This is the methodology, data acquisition and pre-processing. Like dataset collection. I have collected this dataset from Kaggle, and we have 8 different kinds of data in this. Pre-processing techniques. Key steps including noise reduction via Gaussian filters, histogram sequestration for image contrast, and segmentation to isolate fingerprint regions, and normalization to a standard 256 into 256 pixel size. This is the CNN model architecture. Like we have layer configuration. The CNN consists of multiple convolutional layers using varied kernel sizes, followed by relative activations and max pooling to reduce dimensionality. This is the KNN model implementation. Like we have feature extraction, KNN parameters, and metrics for evaluation. We have used accuracy, precision, recall, and F1 score for like metrics to calculate the evaluation of this project. This is the result comparison. Like using CNN, we got 98% accuracy, and using KNN, we got only 82% of accuracy. Advantages and the limitations. Like why we use CNN for the project is like automatically extract relevant features with a superior accuracy, but at a higher computational cost and a risk of overfitting. Like strength of KNN, simple to implement and no explicit training required, making it lightweight but sensitive to scaling and lower accuracy. We have a future work and applications like hybrid models, diverse data, and healthcare integration. In hybrid models, combine CNN's features, learning with KNN simple classification to leverage benefits of both. For diverse data, expand datasets to include bordered demographics and verifying images conditions to improve generalizability. And healthcare integrations. Deploy rapid screening tools in emergencies and remote locations with mobile applications. Here is the conclusion. In conclusion, CNN models demonstrate superior performance for blood group detection using fingerprint images. So can I show like my website?
Yeah, please
Hello?
go ahead. Yeah, please go
Yeah.
ahead.
So can you see my screen?
No, it's the same PPT screen.
Okay, 1 minute. I think now you can see.
Oh, yes.
So this is the page I created. We have sign up page. We use full name, email, username, password, and confirm password to sign up. And this is the login page. We have to use our password and username for login. So after login, just we have to choose an image from our dataset or any data. So I'm going to choose an image. After choosing this, just we have to click predict data group. So it gives the like which blood group is it like it is included in. It gives O positive.
Okay.
And we have
That's good. Yeah. Yeah, go
we
ahead,
have
please.
about page and methodologies and the data set and technologies we have used.
Okay.
This is the data sets and it is contact details.
Okay.
Done.
Yeah, that's good. You showed something working example.
Yes,
I
sir.
really appreciate it.
Yes.
What is the accuracy of this system?
So for CNN, it is 98%, sir. Like
Uh,
we are using not real world examples, just we are using a data from the data set, sir. If we use
hmm.
real world examples, we get like 84 and 85, sir.
Do you think for the medical purpose, this is the accuracy acceptable?
Yes, sir. But like we need to improve more features. Like we need to collect a real world data. So if we train a
Uh,
model, if we train our model on real world data, so it can give a better accuracy.
I totally understand your point of view,
Yes, sir.
but for the medical point of view, medical thing, we need 100% accuracy. If someone
Yes, sir.
want to transmit the blood or some other
Yes, sir.
thing,
Yes, sir.
right? And these days, we already have some kits, very
Yes, sir.
cheap kit, not too costly, and it can give a result in 2 minutes.
Yes, sir. Yes,
You
sir.
know, less than that.
Yes, sir.
So I'm just thinking, what is the purpose of fingerprint where the accuracy is the less as compared to where we need 100% accuracy?
Yes, sir. So it's actually giving a 98% accuracy. Like we have to train a model on like real world data, sir. So we need to collect it, lots of data from our like nearest hospitals or any labs. So by collecting those samples and training this model on the samples, we can get like like accuracy of up to 99 or 100, nearly 100.
Uh, I understand, what you're trying to do it, but my point is very simple. In
Yes,
the
sir.
medical world, we need 100% accuracy,
Yes, sir. Yes, sir.
especially for the blood transmission.
Yes, sir.
Even if your system can provide a 99% accuracy, it's not acceptable
Yes, sir.
because out of 100, 1% can die or
Yes,
have
sir.
some other issue due to this system.
Yes, sir.
So this is just a feedback, where
Yes,
we
sir.
need 100% accuracy, we need 100% accuracy.
Yes, sir. Sir, we'll try to get 100% accuracy in like in future.
Uh, that's right, but already medical kit is very cheap, can give a result in a minute.
Yes, sir.
In my point of view, think about it,
Yes.
right?
Yes.
So probably you can look some other application for this,
Yes, sir.
uh, instead of actually medical purpose.
Okay.
Okay,
Yes.
okay. Thank you.
Thank you, sir.
Thank you so much, Mr. Rachila. Thank you for your valuable contribution to our discussion. I would like to extend my gratitude towards your presentation. Thank you. Now I would like to invite Mr. Abhijit Khare. You can continue from the point you've left. Mr. Abhijit.
Why?
Abhijit, you're not audible.
Yes,
You
yes.
are.
My bad. My bad. Am I audible?
Yes, you're audible, but you're not visible.
Let me. Yes, yes. Hold a second. Uh, am I visible now?
Yes.
Okay. Sorry for the issues. Actually, I faced some technical issues. So basically, let me introduce the topic again. So this basically our work is on exploring the intersection of artificial intelligence and mental health, as artificial intelligence is booming, and also the concern for mental health of students, as we see a lot of students and people are actually getting subjected to mental health issues, and which causes them to do certain actions which are not uh, helpful to the society as well as to them, right? So let's understand. First of all, I would like to thank Amity University for holding this conference and giving me the opportunity to present my work. Uh, my I would also like to thank my co-authors, Professor Hina Khanna ma'am, uh, Dr. Rupali Dev, Dr. Manik Mehra, and Hadia Mirza and Priyam, right? So, first of all, what our aim is in this research is to use Python tools, right? Python kits, Python libraries to actually analyze mental health factors for mainly focusing on college students. Uh, we will basically machine learning, or you can say data science, can actually help us in mental health in multiple fields, like understanding how understanding like pre knowing of knowing if someone is going to face some mental issues. Also, if some understanding if someone will face some critical attacks or problems, and also also help us understand which methods can reduce are the best in reducing these kind of symptoms, right? So the outcomes of this research, hold on a second, please. So basically, first of all, what is mental health? It is the emotional, psychological, and social well-being that affects how individuals cope with stress and make decisions. We will basically immerse use in Python libraries like NumPy, Pandas, and Scikit-learn, and understand how we can do an early detection and do personalized treatment of these mental health issues. Right. Before starting moving forward, I would like to share how already AI is revolutionizing in the field of mental health. Like there are AI has been increasingly used to develop virtual therapists that are offering a lot of insights and also personalized treatment plans uh, to patients having mental health mental health disorders. Right. The main these two highlights that AI chatbots are reducing depression symptoms with a 64% greater reduction in depression systems, and also predictive models that can predict with an impressive 92% accuracy of suicide risks, right? So these are some of the interesting achievements that have been achieved by AI. This is a literature review which we used in understanding and creating this research. The methodology of our mental health analysis paper would be like went like data collection. We gathered mental health indicators from public data sets. We created our own.
Abhijit, kindly discuss your research work and your uh, methodology so that these things we are well aware about this. So
Okay, okay,
please
okay.
focus on your work, your data
Yes,
set, and your outputs.
yes. So basically, what we yes, I would take that into my piece. So basically, in the data collection part, we created our own form, and we curated our own questions, which were based on college students, and which would actually help us in understanding uh, the basis of how mental health is affecting this. Right. I'm sorry. So. we ac- uh, we actually went like trained four different models like decision tree, SVM, random forest, and KNN to predict which of them like to predict the depression and also to understand which particular model is performing the best. We used evolution metrics like accuracy, precision model, recall, and F1 score to compare the models and understand where we need to work upon. The libraries that we used, I have already mentioned for the which for the scikit-learn for classification and regression clustering and all that. So in the study, we found out that models that the scores of the models, we can see that SVM performed uh, really well with an accuracy of 0.83 and precision of 0.94. Other models were also great, but SVM outperformed them. And there will be, let me share. So this is a bar chart which showcases how well the accuracy scores were. And also, this was the dataset collection format. This format was utilized because which actually incorporates both the personal insights and also their uh, academic insights, which help us to understand, uh, which help us to capture what actually affects the mental health, right? So the results are in the graph. What were what was different in the proposed model and the traditional model is that the data set we used is collected from Google Forms rather than using older data sets, and also understanding that if we can tailor the questions as well as the models according to the needs, right? We have used Python libraries for the cleaning of data set rather than manual cleaning, and also machine learning algorithms and evaluation metrics are specified, right? So coming, sorry, one second. Just having too much issues. I'm sorry. This is, yeah. Yep. So So coming to the conclusion, we've seen that how data science and AI is affecting uh, the mental health, and also how it can be further used in understanding how mental health can be curated, and also how mental health issues can be uh, predetermined, and also uh, understanding in which factors affect mental health, and also which factors will help us in improving the mental health of students. Thank you, and I would be happy to take any questions.
Abhijit, can you go to a slide where you have the all inputs, the 9 inputs?
Yes, sir.
All right. So these are your data set, right?
Yes, sir.
9. So
Yes, sir.
if your data set is just a 9, right, why you need to use a AI for this?
So, sir, basically,
We-
yes, sir.
This
So
data
basically,
set
sir,
is this data set is, you can have a permutation on that, and you can have the 100% accuracy.
yes, sir. Basically, this research was not in the not just to. It was just an, you can say, basic understanding of how AI is actually how AI can help us understand like the mental health, and help us in doing right, help how it is revolutionizing and how it is affecting which particular models can be used. It is not like we can also like improve, and also we can also like add more and more variables as much as we need and as we understand more and more. But like for a basic understanding and for a base settings, we have used these 9 questions.
Okay. And how you can validate the result?
So, sir, as you have seen that we got an accuracy of like 0.84, and this basically it was also basically confirmed, and prevalence of the mental health conditions, as you can see, that which uh, particular you can say particular issues, mental health issues were faced, and also how how the model actually was able to predict, right? Basically, how good it was in predicting these issues.
Okay.
Abhijit, you in your data set there are only 9 variables out of 5 is something which is the prelims information of any individual one.
Yes,
So
sir.
in that case, how you can evaluate mental health, right? And the diagram showing some bar charts, it's a simply data collection through Excel as you mentioned in your PPT. So so there is no sense of using Python, Tableau, and other tools in that particular scenario. So why you are mentioning these tools in it? It is just just computing the output through Excel only.
No, yes, sir. Yeah, I understand you're trying to say, but sir, basically, what we have.
And when someone talking about behavior, mental health, and other related issues, it is something which is really into some depth. If you're asking, are you depressed and anxiety and panic attacks? So this is very obvious, right? And if someone is depressed, you can't say uska mental health kaisa hai, right? This is something, it might be situational based. So
Yes,
your
sir.
questionnaire having only 9 questions out of five, first five has no worth at all. Right. So if you try to evaluate last 4 questions,
I
I don't
understand
think
what you're trying to
it
say.
has something
I'll
which
work
is
upon it.
valuable, something you find something which is valuable from it.
Yes, sir. We will work upon it, sir. I
So this is
understand
my
what you are trying.
suggestion. Please enrich your data set and do some valid comparison uh, through whatever data set available on net. Right?
Knowledge, sir. Yes, sir.
Yeah. Thank you, Vijit.
Thank you, sir. Thank you for having me.
Thank you so much, Abhijit. Thank you for sharing your insightful research with us today. Now, I would like to move forward and call Mr. Ashutosh Kumar, the paper ID 247, with the topic Smart Mirror with Deep Learning for Health Evaluation, Skin Care, and Virtual Enhancement.
Yeah, let me know if I'm audible.
Yeah, you're audible. Please start.
So is my screen visible?
Yes.
Okay. So good afternoon, everyone. My name is Ashutosh Kumar, and I am a second year undergrad from Lovely Professional University. So today I'm honored to present our research paper titled Smart Mirror with Deep Learning for Health Evaluation, Skincare, and Virtual Enhancements. Okay. So I led this work along with my co-authors, and I'm presenting on behalf of our entire team. So our background is basically in AI and computer vision, with a shared interest in building tech that integrates with everyday life, especially in health and wellness domains. Okay. So this project explores how a mirror can evolve from a passive reflection device to a proactive wellness assistant using machine learning and augmented reality. So moving towards the introduction, so let's begin with the introduction and the problem we set out to solve. Okay. So traditional mirrors today are a singular purpose, and that's nothing but just reflection. Okay. But in this tech-oriented generation, we expect our technology to do more. So here we come into the play with the integration of machine learning and augmented reality. We are proposing a smart mirror that doesn't just reflect, but analyze your face, detect skin conditions, simulate makeup, monitors emotional states, and even connects with smart home devices for a complete wellness ecosystems. Moving towards the research gap, we identified some key gaps in existing solutions that were lack of personalization, no skin feedback, no emotional understanding, and zero integration with smart devices. So our solution addresses all of this in a single system. So our system bridges all of these gaps by combining machine learning, augmented reality, and IoT all in a single system. Okay. So moving towards the objective. So our core objective were to analyze skin health, recognize emotions, simulate makeup virtually, and connect with smart home environments. Okay. Ultimately, we wanted to make a mirror that understands and responds to user. So we had four main goals for that. The first one was real-time facial and skin analysis. Then the second one was AR-powered makeup simulation. The third one was integrating with the smart home systems, and fourth and most important was the higher accuracy and the user satisfaction. Moving towards the methodology. So here's a breakdown of how our mirror is going to work. So first a high resolution image is being going to be captured from the camera, which we will be installing the mirror. Okay. Then we will be detecting the facial landmarks with using the tools like OpenCV or DLib, like eyes, lips, jaw lines. Then we will be applying deep learning models like CNN for skin condition classification for detecting if there is any pigmentation or reality, and will use GAN models to overlay the makeup simulations in real time. Okay, so the results will be displayed on the same mirror by either a render face model or a mesh model, in which it will be looking same as of the user, and the user can customize their personalized makeup or anything in that, and they can see what they applying what at what amount can, and what will be the output that they will be looking like. Okay. So moving towards the data sets and models we used three data sets. First one was a celebrity faces data set. This was a 2 lakh images data sets, 2 lakh plus image data sets for of different celebrities. Okay. Then we used DermNet dataset for skin conditions like acne or wrinkles identifications. Then we use FER 2013 dataset for emotional recognition. To be specific, we used CNN models, and that was a MobileNet V2 model which we used, and for skin and facial analysis. The second we used GAN model for Style GAN 2 for makeup simulation. Then we use LSTM long short-term memory for emotional state tracking. And then we just are trying to combine all the outputs of these three models in some, and trying to create an ensemble method which is going to combine all the outputs of these three models and give the and share the valuable insights of that. Okay. So moving towards the results, our CNN models performed the best, giving 92% accuracy and with a high processing speed. Then we used GAN, gave us a bit lower accuracy with 89% accuracy. Then RNN gave us 85% of accuracy in emotional prediction, and all combining all hybrid system gave us 90% of accuracy, combining all of the same. Okay. So moving towards the findings, we found that CNN can be used for real-time facial and skin analysis with high precision. Users preferred we also took a survey in our college of like if we are going to create a mirror of such time, so will the users are going to consider it against this smart traditional mirrors. So users prefer with the outputs we were happy to see that the users were willing to prefer the smart mirrors. So users were also willing to this was also excited about this augmented reality based feature for makeup and makeup simulation, and that they also appreciated for this. So moving towards the implications, so this thing, the smart mirror has many implications. First, like for the users, it can be like they can virtually visualize the for the makeups and anything. Okay. The second users will be for clinics and dermatologists for mental health tracking and early stress or mood detection. The third would be for if there is a product or something and they want to sell it, they can just provide a valuable insight where user can just use it on with our smart mirror and see what is going to happen when they are going to use that product or anything. So this will stop causing the manufacturers the returning things. The people will trust them. The product will not be returned or anything. So these are the implications we are planning to have on our mirror. So thank you so much for having me here, and I would like to open the floor for any questions if there.
Hi, Ashutosh. And this is really a good concept. So, did you implement anything in that?
Implement means of your
Means,
the hardware.
yeah, means,
We are working upon that. So actually everything was just set up, but in our college, but due to some circumstances, our
uh-huh.
college closed and we are been sent back home. We have all the
Okay.
models and designs, everything is been ready, and we are just the frames and everything has been implemented. So the thing which was we were lacking was with the render facial structures. So that is what we were having issues with, and we were just working upon with that. So but just because the college got closed and
Right.
the things
Okay.
got
So,
stopped.
what hardware you are planning to use for rendering purpose?
So see, actually first we are having a frame, okay. Then we will be implementing a screen, a display. In that everything will be there. Okay, in the back end for the hardware we are thinking of implementing some cameras, okay, with some sensors for connecting with smart home devices for lighting conditions or anything regarding to that, like for a perfect image capturing, so that if that image is got clear, then only the model which will be created on the screen will be better. So that is the hardware which we are trying to implement.
Um, so if I understand correctly, you are planning to use one display,
Yeah.
one
Yeah.
mirror kind of the display,
Yeah. Reflecting display.
and reflecting display with camera.
Yeah. Yeah. That is the thing.
Okay,
And all the
right.
things will be done, evaluated by the software which we are making the ML models. All the
Uh-huh.
input will be given there, and there it will be evaluating everything. So that is how we are.
Uh, did did you actually try to explore the smart mirror,
Yeah, actually
which
we.
have the capability to connect with the Wi-Fi,
Mhm.
right, to render as well. Plus, you know,
Mhm.
through a service, whatever you want to render it, you can do that.
We explored some, but what is the issue in the current things which are currently available? Na? They are one. If I am going to get a particular module, now there is nothing like everything combined in a particular thing. They're module by module. Some are having a particular module in their system. Some are module having a particular module in their system. Some are having a particular module in their system. But there is nothing.
Which model you are talking about?
Anything like if there is any facial recognition thing, okay, so someone is having a mirror something like that, and which is having only a feature with facial recognition, okay. Some are having with connectivity with smart home devices of lighting and everything. Some are having different emotion and everything. So there is nothing where everything is combined in a single thing, single system.
Um, so you don't need all these things. You just need a system
Yeah.
which can display, which
Yeah.
can give the capture and connect with the Wi-Fi or Bluetooth,
Yeah.
so that your web service can process all the thing, face recognition, feature extraction, and it just need to display it.
No, that is what we are trying to do now.
Okay.
Yeah.
Okay. So that's what I'm saying. The smart mirror have this kind of the functionality. You not need to connect with multiple system.
No, actually, we are going to create a single system and having a like backend means all for software running, everything will be there, and there will be a Wi-Fi component or and a Bluetooth component which will be connecting with all the smart home devices for for tracking and everything. Like we wear smart watches for the health evaluations. Like if a person is thinking like the model is detecting you're fat or something, so how much steps or how many exercises you did, so that data can be collected with your smart watches or anything which collects that data. So you are not needed to carry your this smartwatch or anything for everyone, and so that is what our vision is.
Okay, okay. Sure. Best of luck, Ashutosh.
Thank you so much, sir.
Thank you so much, Mr. Ashutosh. Thank you for contributing to our understanding. I would appreciate your time and effort in presenting such a thought-provoking paper. Thank you so much. Now, I would like to call Mr. Mihir Varshine, paper ID 287, and the topic is RAGNET, Enhancing Conversational AI in Medical Domain. Mr. Mihir?
Am I audible? Hello.
Yes, you're audible.
Okay. Can you see my screen? Can you see my screen?
Yes, your screen is visible and you're also audible. Can you?
Okay. So, give me a second. So, good afternoon, everyone. My name is Nirvashne, and I'm here to present a research titled Ragnet Enhancing Conversational AI in Medical Domain. This work aims to boost accuracy and reliability of medical question answering systems using enhanced RAG frameworks. So let me introduce to the topic. Medical question answering systems are becoming vital for healthcare professionals and researchers, but traditional methods like such as GPT 2.0, etc., are lacking precision for multi-step and very complex queries. So RAG was a step forward in this domain, but existing approaches like naive RAG and advanced RAG still facing some relevance issues. So we identified three core limitations: a lack of multi-hop retrieval for complex medical queries, ineffective query refinement leading to irrelevant or hallucinations, and non-modular architectures that limit task-specific tuning. So these gaps laid foundation for our proposed model, and that is enhanced modular RAG system. Our goals were first to improve the factual correctness of medical QA system. Second, to compare model against naive RAGs, advanced RAG, and module RAG on MediQA dataset. And the third is to incorporate multi-hop retrieval, few-shot prompting, and modular optimization into our system. A workflow follows 5 stages. First is data ingestion.
Mihir? Sorry, Nee, there's some technical issue with you, with your system.
There is some bandwidth issue.
I'm sorry.
Nihil,
Yes,
I
ma'am.
think you can switch off your camera, then your voice can be, I think, a little clearer.
So I was at methodology. So we are using 5 stages. First is data ingestion, where we have used MedQA dataset. And second is few shot prompting to guide the model with minimal examples. Then is multi-hop retrieval to access layered evidence. And then query optimization that we'll discuss later. And final is response generation using an ensemble of outputs. There is a diagram you can see there. Now, the experimental setup. For our experimental setup, we use the MedQA dataset, which contains over 12,000 authentic medical exam questions. We evaluated the performance of 3 models, GPT-2, GPT 3.5, Llama 3.1, 8B. And these models were tested across multiple configurations, starting with naive RAG, advanced RAG, and followed by modular RAG. A main contribution, the enhanced modular RAG, was benchmarked against all these to highlight its improvements in both accuracy and factual correctness. Now we'll show the findings. Our findings show significant improvements. Enhanced modular RAG with Llama 3.18b achieved 75.42% accuracy and 81.45% factual correctness. GPT 3.4, GPT 3.5 also shows high gains, 74.4 accuracy by up to 14%. So there has been 2 graphs that are depicting accuracies and factual accuracy for better understanding of the comparative analysis. Next is query optimization. So why are we doing these query optimization? Query optimization is the key in our framework. Rather than setting on the single query execution, our model refines queries iteratively. Each result informs the next query, gradually improving the context and retrieval relevance. This mimics how a clinical might rephrase or refine questions based on previous findings, resulting in better query alignment with user intent, and that will reduce hallucinations, and it will increase factual correctness. So this figure illustrates the performance of the models for various hyperparameter conditions, such that we have taken number of iterations as an hyperparameter, and we are checking against Llama 3.18b, GPT-2, and GPT 3.5. That after how many iterations, like accuracy is increasing or decreasing, what is happening inside the enhanced modular RAG. So the 3 models presented have very different performance profiles with respect to the number of iterations over MedQA. If more follow-up iterations were conducted on MedQA setting, it would appear that GPT 3.5 and Llama 3.18b has improved, and they have demonstrated ability of the framework to enhance the quality of the response through iterative questioning. So what are the implications of the enhanced model RAG that we have proposed? So our approach delivers clear improvements in both factual accuracy and answer reliability. The combination of few shot prompting, multi-hop retrieval, and iterative query refinement results in more intelligent, coherent, and clinically useful answers. This can have real-world applications in clinical decision support and medical research. And deployment, our system is deployable using, we can use Docker, and that can be scaled on AWS. We have also incorporated confidence checks and data encryption to ensure ethical use. However, the framework is currently computationally expensive and lacks multilingual capabilities. Future work includes model compression, more diverse datasets and real-world validation with clinical experts. So thank you for your time and attention. I'm glad to be part of this conference, and now I'm up for any questions.
Nihir, in this, what the thing you implemented?
So we have implemented RAG framework basically. That is, we
Hmm.
have proposed our enhanced RAG framework where we have used multi-hop retrieval. That is retrieving of like maximum example, like 3-4 examples for that for a MedQA dataset. And we have used few shot prompting. Previous researchers have I'm really sorry that electricity is going out again and again.
It's okay.
Okay, so we have also used few shot prompting here, which means we will provide some examples by ourselves. So the previous
Mhm.
researches that I've been through have used one shot prompting and like no shot prompting as well, where I can find that providing more examples will be helpful to the system. Also, we have used three models so that ensemble of outputs, the output which has highest accuracy, will be provided to the user for medical purposes.
Can you go to a slide where you did a comparison?
This slide, sir.
Right. So I want to understand how you conclude the comparison thing.
So actually we went through all the RAG approaches. We made naive RAG,
Mhm.
advanced RAG, and modular RAG, and our proposed
Mhm.
enhanced modular RAG. And when we performed same operations over GPT-2, GPT 3.5, and Llama 3.18b, we got different of blue score. That is basically how you select these for textual data. So for naive RAG with GPT-2 model, we got 59.42% accuracy. And for enhanced model,
This is my question. How you come on this figure 59.42?
so after calculate, we the work we have done, like we there is two data set basically. One is we split the data into two parts.
Mhm.
One is the test data and other is train data. So
Okay.
when
Okay.
we we implemented test data into for the final validation so that we can get the final accuracy.
Mhm.
So that is coming out to be
No,
59.42%.
no, got it. It's really good. So last thing, how you can improve this from 75.42? Do you have any
So
plan for this?
yes, actually, what we are trying to do is to that like GPT 3.5 API we are going to use so that they have more tokenization number. Like tokenization is good in GPT 3.5 tokenize, and also we are trying to use FAS here, FAISS, and that is a Facebook system, so that we can gather more information about we can gather more information in the particular field.
Okay, sure. Thank you so much to explain me this thing.
Thank you, sir.
Thank you, Nihir. Your presentation was quite informative and engaging. Thank you for joining us today. Now, I would like to move forward and call for the last presenter for today, Mr. Uday Raj Pandey, paper ID 248, and the topic is AI integrated smart band-aid with automated bound monitoring and dynamic drug delivery system. Welcome to the session, sir. Please start with your conference presentation.
Hello, ma'am. Am I audible to you?
Yes, you're audible.
Okay, ma'am. Wait a second.
Can you be a little louder?
Yes, ma'am. Now it is okay.
Nah, yeah, fine.
Okay, ma'am. So, good afternoon, everyone. Myself, Uday Raj Pandey from lovely Professional University. Our topic is AI integrated smart bandage with automated wound monitoring and timely drug delivery system. In this PPT, we are going to discuss few points like introduction, literature review, methodology, result discussion, conclusion, and future scope. So, basically, our this smart bandage is based on artificial intelligence, which which is different from traditional dressing systems or traditional bandage, because they have not ability to uh, take decision that how to give medicines, how to apply medicines or whatever according to the situation. They are manually done by the doctor when patients reach to them. So, sir, in case of our bandage, we have integrated AI to them. So that's why it will take a few records of wound like pH value, moisture of that wound, temperature, and bacterial activity. Based on this, it will uh, decide that what to do. Now, sir, here are main six uh, literature reviews, which plays major role for our project. Basically, we have read 16 to 17 papers, but these are the changing points for our model. Sir, now in methodology, sir, how are these bandages working? Sir, first of all, it collects when as we apply that bandage on the wound. Sir, first of all, it collects the data, means it already having sensor. So, sir, it start collecting data regarding how much temperature of that wound, means that wound area, what is the pH value of that wound area, how much moisture is there, and how much bacterial load or bacterial activity is seen there. Sir, based on that, sir, our model will decide, sir, that uh, in our that's our bandage, there is basically have three features. First one is it can monitor by the doctor. Second is that if wound is little bit average, means it can be handled through that bandage, then it can start implementing medicines and all based on previously trained data set. So it can, if the risk is minimum, then it can handle that situation by its own. Otherwise, it can send notification to doctor's end. Sir, it is connected to their interface also, doctor's interface. So, sir, it can send notification there. So that he can manage the situation is getting little bit worse. Otherwise, last option is that, sir, suppose if there is a severe wound, sir, which can't be handled through that. So, sir, then it gives alert to patient and doctor that you have to visit to doctor. So, sir, like this, our bandage is working, and when the wound is healed and treatment is completed, it automatically gets deactivated. Now, sir, here is the prototype of our bandage. We are currently working on this the prototype, sir. And sir, here is the flow chart of what I have explained, sir. Here is complete working of our model. That's how it will detect wound and how it will, sir, make decision that what a person can do. Either it can be healed through that bandage only, or he have or doctor have to do his interference into that, or sir, last thing is that the patient have to visit the doctor because wound is serious. Now, sir, we will try to use these 4 or 5 models like CNN for through imaging sensors in that bandage. It will collect the image of that area. It will process the image. Then, based on that, it can decide the condition of wound. Then, sir, a random forest for decision making based on the taken data from sensor, which is inside the bandage. Next thing is, sir, LSTM, sir, long short term memory. Sir, it is used for uh, storing information that, so that it can work better for next time. Then, sir, we have clustered the categorized the wound into 3 parts: mild, moderate, and severe. Sir, as I have told, if it is mild, it can be handled through that. If it is moderate, then patient does not need to go to doctor. Doctor can handle from there only. We can monitor from there only. Either if it is severe, then sir, we have to go. Now, sir, reinforcement learning for uh, improving that bandage by itself based on given data. Sir, here is comparison. Sir, basically, I have taken consideration 3 type of bandages. Sir, the last one is AI integrated, which we are going to implement. Sir, here is already traditional bandages there and some smart bandages also there. So, sir, in traditional bandage, we don't have any real-time monitoring, but in our which some bandages which are present, which are smart bandages. So, sir, they have limited monitoring system, but sir, they are not that much accurate. But sir, in our case, it is advanced AI integrated, sir. And sir, medicine delivery, sir, in both traditional and currently existing smart bandage, they don't have uh, any feature of delivering medicine through itself. But in our case, sir, it will be automated. Then, sir, remote supervision. Sir, it is not available in both the bandages, sir. But in our case, it is possible, sir. Then, sir, self-healing. Sir, we have we have tried to use polymer-based materials, which can be means bandage can be self heal, sir, if it got stretched or something, so that it can repair itself. Now, sir, personalized treatment, sir, in traditional, no chance. In existing, it is limited. And but, sir, in our case, it is AI driven, sir. Bandage can able to do treatment. Then, sir, infection prevention. In traditional, there is uh, no any such kind of things to prevent infection. In existing smart bandages, sir, it is basic. But sir, in our case, it is AI powered, sir, because it do medication time to time, sir, so that a wound environment is such capable so that it can heal that area. Now, sir, if we will implementing this, so sir, we can increase the healing rate more than 35 to 40%, which is of right now, which is of traditional bandage. And sir, infection risk is reduced, sir, less than uh, sir 50%. Uh, means sir, infection risk is very much minimized. Uh, Now, sir, in conclusion, sir, I want to say that our this bandage, sir, it can bring revolution in currently traditional tracing system, sir, because it don't have real-time monitoring or automatic treatment system. But sir, in our case, sir, it is possible, sir. Sorry, sir. Sir, in case of future scope, sir, we will try to minimize the sensor size and we will try to make our model much more perfect so that it can be used in many other scenarios like in military purposes we can give it to them in space missions who are going to space, sir, we can give it to them also like this, sir, we can use it in various ways. So this is our presentation. Thank you so much, sir, for listening. Sir, if you have any question, you can ask.
Uday, that is really a good concept. So do you
Yes, sir.
have the bandit, the smart AI
Yes, sir.
bandit, or
Uh, yes, sir. Yes, sir. Sir, we are currently started working on that, sir, but situation is a little bit not good in our college, so sir, that's why we have sent it to our home. Sir, I'm from Lovely Professional University. So, sir, but in there, we are with our co-author and our mentor, Angela, sir. Sir, we are working on that hardware model. We
so
are trying to,
it's
yes.
still work in progress.
Sir, still it is in
F-
progress.
And in the result, you mentioned some improvement. How you reach on that point if Bandit is not ready?
Uh, sir, sir, pardon, sir. Once again.
Um, if I can understand correctly, the Bandit work is in progress, the
Yes,
hardware thing. And in
yes.
the result, you mentioned the some improvement, like a 30 to 35%.
Yes, sir. Sir,
So how you reach on that point?
sir, it is our, sir, approximation, sir, because, sir, just we take a scenario that a person is dealing with, he having a cut on his hand, sir, and sir, suppose he is not able to go to doctor with due to some reason, sir, suppose he is so much aged. But sir, if is going to try traditional bandage, then sir he have to go to doctor. He have to take that bandage. His health is also not good. So sir, if he will avoid that. So sir, it may be increased. The risk of infection may be increased. But sir, in this case, sir, we can just implement it and it is activated by doctor, sir. Anyone can bring for it. But sir, for traditional bandage, we have to go there. So sir, just as doctor activated, so sir, we can start treatment. So sir, by that we have approximated that it must be better than that, 30 to 40% better than that. And sir,
No, I
we
understand your point. I understand your point correctly. So probably either in the sheet you can have the proposed, you are
yes,
thinking
sir.
it may improve this much of the percent,
Yes, sir.
or you have some result to validate it. And
Uh,
yeah, it's really good concept. And I have a one last question.
yes,
You
sir.
mentioned about to take the image from
Yes, sir.
the in the Band-Aid. You are
Yes,
planning to use camera. What you are planning to
sir.
use it to take
Sir,
an image?
sir, sir, uh, we will use, sir, something kind of imaging sensor, sir, which can work, uh, sir, in that situation also. Because, sir, if we implement camera, so, sir, it needs light and all. So, sir, because without light, sir, it is a little bit hard to capture the image of that area. So, sir, we are
So do
in search of some kind of that sensor.
okay, so that search is still in progress.
Yes.
Okay, okay. Yeah. Thank you so
Sir,
much, Uday, and best of luck.
sir, any more
Yeah.
feedback, sir, which you want to give?
Sorry.
Sir, any more feedback, sir, which you want to give?
So I will just say, start with the basic thing, right? If you can
Okay.
have any kind of the smart bandit,
Yes.
just
Yes.
just to deliver anything,
Yes.
either it
Yes.
can deliver a medicine
Yes, sir.
or it can have a Wi-Fi connectivity to provide any sensor data. If you can
Yes.
figure it out that,
Yes.
start with a step by step instead of just going all the way.
Okay.
Yeah. Yeah, the concept is really good, Yeah.
Thank you, sir.
Thank you so much, Uday, for your insightful presentation. We really appreciate your time and effort that you took out for this presentation. Thanks a lot. Now, I would like to call Mr. Edwin, paper ID 248.
Before that, Uday,
Yes.
Yes.
uh,
Yes, sir.
so there are some nanorobot to deliver the thing. You can explore those as well.
Nanorobots, sir.
Yeah, nanorobot, and plus
Yes.
there are some company which do,
Yes, sir.
like delivery of the medicine using some kind of the similar system.
Yes, sir.
So you can look on those things.
Sure, sir. I
Uh,
will.
yeah, I don't remember the company name, but I believe it's some name like a Titan or something.
Okay, sir.
So
Sir.
they have a delivery mechanism.
Okay, sir. I will
Yeah,
try it,
yeah.
sir. So, thank you,
Okay,
sir.
okay.
Thank you, Uday. Now, I would like to call Mr. Edwin, paper ID 249. The topic is dark web complications, policing and surveillance, challenges and implications. Mr. Edwin.
Yeah, can you hear me? Am I Larabo?
Yes. Yes, you're audible.
Okay, thank you.
But you're not visible. Can you turn on your camera?
Okay, I must say that I'm using my phone for this presentation. Just a moment. Mm. Okay. Yet, I hope I'm not visible.
You're visible.
Okay. I must say I'm very sorry. I'm going to present this extempore without actually using any slide, because in fact, I've not got the information about presentation in time. After submission, I've tried severally to get information about presentation, the day and the time and the mood, but
So I want to ask the session chairs if it's okay if he's presenting without slides.
Sure.
laptop. I just happen I'm going to do this offhead.
If you have the papers, you can show in
It's
between.
fine, but I believe you have paper with you, so you can share your research paper and Just
it
go
on
ahead with
my
your presentation.
phone. I'm not in my office. I'm not with my laptop. I will just call to do presentation. So please just allow me or pardon me to do it this way.
Although it is highly unacceptable,
The topic
but
of our paper
Edwin,
is
is it okay
dark
that we
web.
can share the paper on your WhatsApp? The paper you shared with us, we can share with you on your WhatsApp and you can open it then and then you can do the presentation.
Let me get back. If there's somebody
Yes,
ahead of
ma'am,
me, maybe some
that will
people to go ahead
be
of
the
me.
right thing, ma'am. Anshul, ma'am. So I'll share I am sharing the paper to him on WhatsApp and then he will share it on the screen. Or
Edwin, if you're not present your paper right now, it not will be published. So
Then
it might be I
just
share
help
from
me to just
my
present
own
right now.
side.
I'm ready to present. If
Okay.
only you can allow me to do it off head.
But it is very surprising you don't have your paper right now. Because somehow
Yes,
directly,
because
indirectly, it must belong to your own login or Gmail or any
in
paper.
fact, I've not received any information. I kept sending message. When is the day for my presentation? The link, they just got to me. Sorry, they just got to me. I'm ready to do presentation, but it will be extemporary.
We're sharing the paper with you on WhatsApp. Please share the screen.
Okay. Share screen.
Wait for a minute, we're sharing.
Yes, I'm going there to share. Share screen. Because I'm using phone.
This is your paper. It is visible to you?
Yeah. Yeah, it's visible to me.
Okay. So go ahead.
Of our paperwork complexities and implications. For a very long time, the environment of the dark web has become an issue to governing authorities and authorities that are relevant to keeping our cyber environment very serene or very clean of evil activities. The dark web is actually a layer of web services where illicit activities most of the time take place. Even though there are also legal activities, but mostly illicit activities, such as selling of drugs, selling of passports, and even the bad guys are able to harness credentials and codes of cards like ATMs and even sell on the dark web. So we found it necessary to conduct a research in this environment. And we found out that it's very difficult even for authorities to trace the individuals who are involved in engaging in these illegal activities. One of the reasons is because of the environment of the dark web. The traders who exchange or who sell one product or the other, which are most of the time illicit, they hide behind the internet because the web or the aspect of the internet that they explore is such that their identity is hidden behind onion of layers. It's like onion that have layers. Before you are able to intercept, decipher, and be able to arrest any of the individuals involved, it takes a whole lot of processes of decryption, encryption, decryption, and decryption, and investigation. And in fact, authorities of countries and nations are finding it difficult to track down individuals who are involved in this whole activity of trading on the dark web. The current data of the amount involved in the dark web activity is about 4 billion plus as it stands now. And day by day, the activity keeps increasing. Some of the activities of the dark web include personal data breach and identity theft and etc. And personally, we try to scan some of the websites of the dark web, and you realize that this internet.
Come to the point and discuss about your work, Edwin.
Okay, so basically what we did is to also find out the authenticity of what actually the dark web looks like. That's how we have to explore by scanning. When we scan, we realize that the dark web is hidden behind sophisticated firewalls, and also ports are closed. Essential ports are not open. You cannot really access them. Some of these are 22, 80, and 4434, file sharing and all of that. We do recommend measures where the authorities that are relevant or are connected to policing the dark web can embark upon to be able to track down the individuals. One of the measures we offered is harmonizing cybercrime laws, because we read that from country to country, the laws are different. So it puts impediment on the authorities to also enforce the law. Another of such is to enhance law enforcement coordination, where it can become a global, there should be Interpol, and it should be a global issue. It shouldn't be narrowed down to country to country. Then also building public-private partnership. The private organization should be involved, individuals should be involved. It shouldn't be just the authorities such as the police or the army getting involved. And there should be room to encourage whistleblowing or whistleblower protection. If I happen to give information, maybe I'm a security expert, and I happen to give information about what is going on the dark web, or individual who trades on the dark web comes out to give information, there should be the guarantee to protect the individual. Then also enhancing public awareness. In fact, a lot of people are not really aware of the dark web, but if knowledge is enhanced about what goes on, and there are individuals who are even training on the dark web who do not actually know that the dark web activity is nefarious or is bad to engage in. So if we can leverage on all of these aspects of accommodation, the dark web can become a better place. And there are emerging technologies also that the authorities can embark upon, like artificial intelligence, implementing artificial intelligence, and also automated crawlers, and also helping the use of the anomaly detection. If all of these are employed, the dark web can, the bad guys who do business on the dark web can easily be tracked down. We also try to use Tor, because most of the in India, we realize that the layer passes through proxies. The first proxy from India is Germany. We are browsing. Oh, we have not even installed any VPN on it. At the bottom in the figure 7, it is obvious that the browser is giving us that we are browsing Italy and we are browsing through Poland. Meanwhile, we are browsing from India. And we've tried this on 2 different websites on the dark web. India is not even showing here. So this is how difficult the issue of the dark web is. Not until we implement artificial intelligence that can, and blockchain and all of these latest technologies that can help us to actually narrow down on the individuals and help to know the exact source of the one who is browsing, the dark web is going to be flourishing, and it keep flourishing. So this is what we have done on the dark web. And for sake of time, I can conclude here for any questions. Thank you, sir.
So what are the findings of your research?
The
Findings and
findings are that one, the dark web is still flourishing. Every activity that the policing force is embarking upon to track down the dark web patrons and to also close down sites is never working. The more they try, the more new. If they close down one today, another service on the dark web surfaces up. That is one. 2, the issue of different countries trying to police the dark web based on their separate laws is not helping to track down the dark web activity. And also the encryption that is available to the dark web services, where they are able to encrypt the dark website that is difficult to actually trace someone who patronizes the dark web is a difficult situation.
Thank you, Edwin.
But this is a basic thing for a dark web. On what principle dark web is based on? You know, the free way of communication.
Mm-hmm. Yes.
So here is everything is free. Free means
the free way of communication. Yes. Who engage in
why and how, you can try to impose something on that.
So that's why we are saying that if authorities want legal business to be done on the dark web, it can solely be tailored towards legal business. But it's also bad for illegal business to be growing day by day. So there should be a means to track down on illegal business like the drug trade, which is increasing. the illegal sale of weapons. And if we don't track down these sites and close them and stop these activities, since there is a rise in illegal or illicit sale of weapons, we can be rest assured that there is no security, physical security, because weapons are being sold every day. And also sale of credit cards. Credentials of credit cards are sold on the dark web. And that is what is also causing the increase in the theft of identity, theft of people money from the accounts, diversion of money from accounts. So, sir, we are of the opinion that if the dark web can be sifted, then good business or legal business can continue over there. But there should be a way to take off the illegal business. Otherwise, then the dark web must be closed, because the illegal business is day by day increasing more than the good. The bad is getting more, or is having upper hand over the good. So what do we do in this case?
No, I understand your point, but it's totally decentralized.
Okay.
Okay, it's good approach. You are looking for something.
Please, maybe I didn't hear the question well. If it is a question, then I didn't get it clearly. Hello, sir. Is it a question?
No.
Okay,
Yeah,
okay.
I'm good. Thank you so much.
Thank you too. Thank you for the opportunity.
Thank you, Edwin. Thank you for your time and effort, and thank you so much. We're really grateful.
Thank you.
Thank you all for participating in this conference. Your contributions and engagement have made it a success. As we conclude this conference, I would like to extend my great gratitude to all speakers, attendees, and organizers for their hard work and dedication. It's been an honor to host this conference. Thank you for being part of this, and special thank you to our session chair, Mr. Alok Jain sir, for taking out your precious time for us and joining us in this conference. Thank you so much.
Yeah, it's my
Thank you
pleasure.
so
Thank
much,
you.
Alok sir. Thank you so
Yeah,
much for giving your time
yeah, thank you.
and
Thank you
efforts.
so much to give me the opportunity. Yeah,
Thank you, sir.
thank you.
I request IT team to please end the session.